Section 7.1.13. The graph to the right is the uniform probability density function for a friend who is X minutes late. If we take a look at this density function, the horizontal axis is the time, and it's going from 0 to 30 minutes here, and the density is the vertical going from 0 to 1 over 30. Now we want to find the probability that the friend is between 10 and 15 minutes late. The area under the graph of a density function over an interval represents the probability of observing a value of the random variable in that interval. The probability that a friend is more than 10 minutes late but less than 15 minutes late is the area under the uniform density function between 10 minutes and 15 minutes. So if we take a look here is our graph. So we have 10 and 15. So what we need to do is we need to find out what is the length and the width of this rectangle. So if we take that rectangle out, we can see that the width is going to be 1 over 30 because it goes from 0 to 1 over 30. And we can see that the length is 15 minus 10, which gives us 5 minutes there. So now we want to find the area of this rectangle. So we can see that again from the graph in the previous step, the length of the time interval is 5 minutes because 15 minus 10 gives us 5. Now find the area of the shaded rectangle, rounding to 3 decimal places. So the area is the product of the interval length and the density. So the probability is equal to the area, which is equal to 5 times 1 over 30, which is 5 over 30, which gives us 0.167. Therefore, the probability that the friend is between 10 and 15 minutes late is 0.167. If we wanted to convert that to a percentage, we'd move the decimal place over 2 decimals to the right, and that would be 16.7%. Now, in part B, it says it is 10 a.m. There is a 40% probability the friend will arrive within how many minutes? So what we're looking for is we want to figure out how many minutes it would be. So to determine the number of minutes that would result in this probability, we want to calculate the width of the interval within the rectangle so that the area of the rectangle is 0.4. Well, 0.4 is converting the fact that the area is equal to 40%, and if you want to write that in decimal, it would be 0.40 or 0.4, and that's why the area is 0.4. So now we know here that the width goes from 0 to 1 over 30, right? We know the area is 0.4, and now we want to figure out what is the minutes. So to find the length of the interval, the area is the product of the length of the interval and the value of x minutes and the density. So the area again is equal to the length times the width. So what are we looking for? We're looking for the length. And the length we call this x subscript 0. So that's what we're looking for. So we know the area is 0.4, and that's equal to the length, which is x subscript 0, times the width, which we know is 1 over 30. So now what we want to do is we're going to multiply both sides by 30 over 1, which is the reciprocal of 1 over 30. So 30 times 0.4 is 12, and 1 over 30 times 30 over 1 is 1, which gives us the length, and therefore x subscript 0 is equal to 12. Well, 12 is going to tell us that therefore there is a 40% probability the friend will arrive within 12 minutes.